Hello everyone. In the previous lectures, we have already seen descriptive statistics, what is inferential statistics, and in inferential statistics part, we have seen what is sample, what is population, and what is inference. Now, in the descriptive statistics part, we have seen already central tendency, how do we measure dispersion, and we have sort of built a foundation to understand today's lecture, which is quantile. Now, what is quantile? Quantile is a measure that divides the dataset into equal sized groups or chunks. Let's say this is a dataset, and we have divided the data, let's say, into 5 equal chunks. So these are all equal chunks, and this is what quantile does. Quantile divides the dataset into equal sized chunks. And why quantile is needed? Quantile actually helps us to summarize the data, describe the data, and most importantly, quantile is the first step to find the outlier. So in dataset, we have seen what outlier does to a dataset. It creates a problem to measure the dataset's nature. So with the help of quantile, we can measure the outlier. So this is the first step and most crucial step to find the outlier. Based on how many chunks we are dividing the data into, the types of quantile is categorized. And there are many types of quantiles, but some famous types are this: quartile, decile, quintile, and percentile. So what is quartile? Quartile divides the dataset into 4 equal size groups. Decile does it 10 times, quintile 5 times, and percentile 100 times. So 4 equal size group means this is Q1, this is Q2, this is Q3, and Q2 is also called, for quartile, Q2 is called median, because this is the 50% of the data and this is the 50% of the data, and this is the middle value, so Q2 is median. For decile does it 10 times. This data set is divided into 10 times, and for quintile it is 5 times, and percentile does it 100 times. So we're gonna learn how to measure this quantile, and before that, some important things to remember before measuring the quantile, that is, the data we are working on needs to be sorted in ascending order from low to high. And when we measure quantile, we measure a location. We do not measure the value. We firstly measure the location with the help of a formula. And thirdly, the value of that location. Let's say in this data set, this is the location we have measured, and in this location there must be a value. So this value may or may not present in that data set. And lastly, we're only gonna learn percentile, because percentile will help us to find all the types of quantiles. Let's say we're gonna find decile. So it divides the dataset into 10 equal size chunks. So D1 will be 10th percentile and D3 will be 30th percentile. And if we see quantile, it divides the dataset into 4 equal size groups. So the first quantile will be 25th percentile of that data. If we learn to calculate percentile, we'll be able to calculate every type of quantile. Let's see what is percentile. So let's say you have scored 50% of the marks in an exam. So that would mean that you have scored 50% of total marks in an exam. But if you have scored 50th percentile or 60th percentile, that would mean a whole different thing. Let's say you have scored 65th percentile and your number is 73 out of 100. So that would mean that 65% of the students have scored below 73 and 35% of the students have scored more than 73. So you are ahead of 65% of the students, but you are behind 35% of the students. So percentile represents the percentage of data, 65th percentile, in a dataset that fall below a particular value. This is the particular value. We calculate the percentile with this formula. So this is percentile location, and this is the percentile rank, and this is the total number of value in that dataset. Now let's see an example. Let's say this is the dataset and we want to calculate 75th percentile. So this is the percentile location, this is the percentile rank. The total number of data is 10 plus 1. That would give us 8.25. So this is the percentile location. Percentile location is 8.25. We have already told that we calculate a location, not a value. So location means as the data is sorted. So this is 1, this is 2, 7, 8. So percentile location means the percentile value lies between 8.25, means 8 and 9. So this is 8.25. So the percentile value lies between 96 and 98. So if you want to calculate the value, that would be 96 plus 98 minus 96 and 25% of this difference. So that would give us 96.5. So what this means? This means is 75% of the students have scored below 96.5. Now, and only 25% of the students have scored more than 96.5. Now let's see exactly the opposite. Let's say this is the values of a particular exam, and you want to know that if you have scored 94, what the percentile rank would be, how many students you will be ahead of and how many students will be behind. You will be behind. So for this case, the formula is a bit different. Here the x is total number of values that fall below that particular value. Here the y is total number of similar values, and n is total number of values. For this case, if you want to calculate the percentage rank for 94, the total number of value that falls below this particular value, this is the particular value, it's 6 plus 0.5 into total number of similar values. There is no 94 in this data set. Total number of similar values will be 1, and the total number of values in this data set is 10. So this will give us 0.65, or in percentage it is 65%, 65th percentile. So what this means is if you have scored 94, you will be ahead of 65% of the students, or in the other way, if you have scored 94, 35% of the students will be ahead of you. Means 35% of the students have scored more than 94. So we have learned the quantiles, and this was an important concept to learn to understand the 5-number summary that we'll be seeing in the next video. And 5-number summary is a very powerful tool to describe a dataset, and for that reason we had to learn this quantile. See you in the next video.